Hello again, this is Christian Aprecio. If you have any questions regarding Nastran Solution 200, if you're a student or professional engineer, you can contact me at this email address in the center of the screen. If you want access to the web app we use to perform these examples, feel free to reach me at this email address also. For the remainder of the video, I'll just go ahead and move my email to the bottom right hand corner of the screen. And let's talk about today's example. So far, we've discussed the concept of unconstrained optimization. It's basically the process of finding a minimum or a maximum for a given objective function. We then incorporated an equation constraint. Next, I want to talk about something called side constraints. Basically, think of this as your constraints on the design variables. So here, let's go ahead and first download our optimization example for this example. Let me see what we have here. Okay, now we are going to start off from the previous tutorial, and we're going to impose limits on the design variables. Basically, we're going to give it a lower and upper bound. And let's go ahead and show what happened in the last example. In the last example, the optimizer was free to move in this y1, y2 coordinate system. There were no limits imposed except for the equation constraint. We're going to impose limits on the design variables. So basically, we're going to say that y1 has to be between this dotted line and this other dotted line. So we are going to say that y1 is bounded by 1.5 and 5. We're going to say that y2 is going to be bounded by -5 and 5. So that would be +5 would be this dotted line. So that would be here. And then this dotted line that you see here. Now, where will you see side constraints in a real world engineering problem? If it was a design variable for the thickness of a plate, if it was the area of a rod or a truss member, you have to make sure that those values are always positive. So your side constraint or your lower bound could be a value of 0.001. You want to make sure that they never go into the negative region. There is no such thing as a negative thickness or a negative area. So you want to prevent the optimizer from trying to get you a negative value for that. So that's where you would use a side constraint. Now, starting off from the previous example, you can download the files from the video description below. Feel free to do that and follow along with this example. So like before, we're going to go ahead and download, extract the files, and select them and upload them to the web app. Everything's defined for me. Equation constraint, or the objective constraint or equation is defined. The equation sorry, let me take a step back. The equation objective is already defined. The equation constraint is also already defined. The variables are also defined. But here again, our lower bound is 0.001 for y1 and y2 for 0.001. So we want to add these so-called side constraints. We want to make sure that the value for y1 is between 1.5 and 5. So let's go ahead and type in 1.5 and 5 here. And let's go ahead and do the same for y2, -5 and 5. So we are basically creating a bound or a boundary side constraints for these design variables. One scenario where you would do this is if you're creating your regular property design variable. Maybe you want to vary the thickness, the Young's modulus, maybe the area. You want to make sure that such values are always greater than, or rather, they're always positive. So your lower bound might be something like 0.001 or 1. So here I'm just playing with this property area. Now I've already gone ahead and defined my lower and upper bound, the so-called side constraints. Let's go to the exporter and download a new zip file. Here, let's go ahead and confirm we want to keep this file, and we'll go ahead and download the contents. So what do we expect in the optimizer? So like before, we expect the optimizer to try to go and move towards the minimum, which is here at 0, 0. But the first constraint it encounters is a side constraint. Here you can see that the value for y1 eventually hits the lower bound of 1.5. Once it hits that constraint, it starts to move along that constraint because it can further minimize the objective value and ultimately landing at a value of, let me look at my notes here. We ultimately land at a value of 2.25. So let's go ahead and see if that's what we get. Let's go ahead and start the optimizer. And again, if you want access to this web app, feel free to send me an email at this link or at this address, and I'll get back to you with details on how to get access to the web app. Now, let's go ahead and look at the optimization. We start at the value of 25, so that would be the value of the surface at the starting point. We ultimately land at a value of 2.25. So that would be this big yellow-red X that you see here on the screen. Let me see if I can zoom in here somehow. I believe that's what you get. Here we go. Y1 is the value of 1.5, and Y2 is the value of 0.0625. And the Z value, or the surface value, is 2.25. This is exactly what we have here, 2.25. Let's look at the design variables. We start at a value of 3, 4, and we land at a value of 1.5. And here, this is essentially a value of 0. So this matches what we saw on the previous plot. Now, remember that when the optimizer hit the lower bound of the design variable, it ultimately started moving along the lower bound of the design variable of 1.5. Now here you can see it starts moving along the dotted line. While you don't see a change in the normalized constraints, here this is not where you see the optimization hit a lower bound design variable. When you look at the design variables, this is when you see the side constraint in action. It starts at a value of 3 and then hits the lower bound of 1.5, and then it moves along the value of 1.5, so on and so on, until convergence is met for the objective. And that's what we saw here. Oh, where's my plot? So here it started moving along the value of 1.5 for Y1. So again, a side constraint is nothing more but bounds on the design variables. You will want to impose bounds on the design variables if you're dealing with value or properties that should always be positive. So that's just one example. Now, in the next video, I'm going to cover, let me see if I can see. Let's find out what the next tutorial is about. So the next one is going to be talking about the best compromise in feasible design. So I think I'll go ahead and pause there and do the next video after.